we are studying SOH CAH TOA, right triangles. So why are we studying all of this? What is SOH CAH TOA? Why are we studying it? Well, what we're studying, the heart of it is ratios. And why are we doing it? The ratios of triangles can be used to solve for the lengths of sides and for the angles of any sides of any right triangle. That is the point of what we're doing today. If we have a right triangle, whether it's a special right triangle or any other triangle, we can solve the length of any side or any angle. And that's because of the ratio of the sides. So let's delve into that. So here we have it. Sometimes you can use trigonometric functions to find the side lengths or the measure of an angle. So that's where we're going, the side lengths or the measure of an angle. And it says sometimes, and the reason we have sometimes is it needs to be a right angle. Ratios of right triangles, three sides, are used to define the trigonometric functions, and they are sine, cosine, tangent, and those are the basics that we will use, but they have opposites. The opposite of sine is cosecant. The opposite of cosine is secant. And the opposite of tangent is cotangent. See that each pair has a co. The opposite of sine is cosecant. The opposite of cosine is secant. The opposite of tangent is cotangent. These six functions are abbreviated: sine, cosine, tangent, cosecant, secant, and cotangent, respectively. Okay, theta. This little representation is the Greek letter theta. Let's spell it out. Theta. We're going to become very familiar with theta. Is the reference angle of the triangle. So whenever we talk about sine, cosine, or tangent, it's in reference to this angle theta. So here we are, the six trigonometric functions. Now I'd like you to take this theta. We've made a little typo there. So theta is actually going to be at the bottom of the triangle. And we're going to say that all of these ratios are with reference to theta. So theta, sine, is opposite over hypotenuse with reference to theta. Cosine is adjacent, which, by the way, means next to. Adjacent, the word adjacent means next to. Okay, so cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Cosecant is the flip of the sine, you notice. So we've put it underneath. It's the hypotenuse over the opposite. Secant is the opposite of cosine, the hypotenuse over the adjacent. Cotangent is the adjacent over the opposite. And these are how we remember it. So let's go to the bottom. We call them SOH CAH TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And TOA is opposite over adjacent. So we have a little mnemonic here. All right, let's flip. So we are going to evaluate the trig functions of an angle shown here. So if we have theta, our adjacent side is 6, our opposite side is 8, how are we going to find the hypotenuse? Well, we also know that we have a Pythagorean theorem. Right, so let me just get it on the camera there. We have c squared equals a squared plus b squared. Let's start with that. So we know that c squared equals 8 squared plus 6 squared. Okay, 64 plus 36, c squared. C squared equals, we add those together, 36 equals 100. Well, if I take the square root of both sides, I can calculate that c equals 10. So x would be 10. So using the Pythagorean theorem, I can solve for the third side. Well, now that I have all three sides, let's figure out our trigonometric functions. What is the sine? Sine is opposite over hypotenuse, so sine is 8 over 10. Cosine is adjacent over hypotenuse, so it's 6 over 10. Tangent is opposite over adjacent, so it's 8 over 6. So I have my 3 basic functions. Now how do I get the next 3? Well, I can get the next 3 by flipping the first 3. I know that cosecant is the flip of sine, so that would be 10 over 8, or hypotenuse over opposite. Secant is 10 over 6, the flip of the cosine, and tangent is the flip of the cotangent is the flip of the tangent, so it's 6 over 8, or cosine over sine. Okay. Now, what we want to do is find the values of the trig functions for special angles. We did a lot of work on this yesterday. We consider 30, 60, and please make a note of this is not 90, but 45 degrees to be special angles. So we're going to calculate the sine, cosine, and tangent of our special angles. So we have to the right these special angles drawn out. So how do we calculate the sine of 30 degrees? Well, we know that the sine is opposite over hypotenuse, so it's n over 2n. And if...
Good morning, Glen Burnie High School. This is a reminder that we continue with PARCC testing this morning. Students taking the PARCC assessment in algebra will report to their testing locations as determined by the passes received by their teacher or the testing list sent by Ms. Ferrara. Once again, we have students taking the PARCC assessment in algebra this morning. Please be sure that they report to the appropriate testing locations. Thank you.
Sorry about that. If n were 1, what would the sine of 30 degrees be? Well, that would be n over 2n, the ratio, and that would be 1/2. So the sine of 30 degrees is 1/2. The cosine of 30 would be adjacent over hypotenuse, which would be radical 3n over 2n. If n were 1, that would be radical 3 over 2. The cosine of theta is radical 3 over 2. The tangent of 30 degrees is opposite over adjacent, n over radical 3n, which would equal 1 over radical 3. Can we leave that? No, we can't have a radical in the bottom, so we know what to do. We rationalize the denominator, which means we multiply by a factor of 1, which is radical 3 over radical 3, that's 1. And then we multiply straight across, which equals radical 3. Radical 3 times radical 3 is the square root of 9, which is 3. So the tangent equals radical 3 over 3. All right, let's do 60 degrees. So now we have, I'm going to put a double angle for 60 just to differentiate. What is the sine of 60? Opposite over hypotenuse, equal 3n over 2n. Sine of 60 is radical 3 over 2. Cosine of 60 is n over 2n. N over 2n equals 1/2. Tangent, opposite over adjacent, radical 3n over n. The n's cancel, leaving me with just radical 3, which is fine. I don't have to rationalize that. Okay, let's look at 45-degree angles. So we have opposite over adjacent, 1n over radical 2n, which equals 1 over radical 2. Now I can't have that rational on the bottom, so I rationalize it. We know how to do that. 1 times radical 2 is radical 2. Radical 2 times radical 2 is the square root of 4. The square root of 4 is 2. So the sine of 45 is radical 2 over 2. Now let's look at the cosine of 45. Adjacent over hypotenuse, so that is 1 over 1n over radical 2n. Now I notice that's exactly the same thing, so I'm going to get exactly the same answer. Radical 2 over 2, which makes total sense because the sides are equal. All right, so now let's look at the tangent of 45. Opposite over adjacent. 1n over 1n. The n's cancel. Anything over itself is 1, which equals 1. The tangent of 45 degrees is 1. So I have found all the values for the trig functions of special angles. So why did I spend time doing that? Well, I found the values. Now, I can use those values in a problem like this. Find the value of x for the right triangle shown above. Value of x for the right triangle shown using the above values. So I want to find x here. Well, how would I do that? Well, I have an angle of 60 degrees, and I'm trying to find the opposite value, and I have an opposite and a hypotenuse and an angle. What does that say to me? That says sine to me. So let's write it out. The sine of 60 degrees is equal to the opposite over the hypotenuse. Well, let's look at our chart. The sine of 60 degrees is what? Radical 3 over 2 equals x over 10. What do we see here? Well, because we know this, we can now just cross multiply to get the value of x. And I can say that 10 radical 3, I'm just multiplying that, is equal to 2x. And I can just solve for x. Well, to solve for x, I divide both sides by 2. These 2's cancel, and I get x equals, I just divide the coefficients, and I get x equals 5 radical 3. So I've used what I already know to be true to solve for a value I don't know. All right, let's move on. So example number 3 shows us something. Sometimes you can't use the properties of special right triangles. What are special right triangles? 30, 60, 90, and 45, 45, 90 triangles. 45, 45, 90. Why not? Well, look at this triangle. It's a right triangle, but it's not 30, 60, 90, or 45, 45, 90. But I can use SOH CAH TOA to solve it. What do I have? How can I do that? Well, I have an angle, I have an adjacent angle, and I can solve for the lengths of the sides. Let's do it. I can say, let's solve for C first. I have an adjacent, I'm going to solve for C, I have an angle. So that's cosine. I can say that the cosine of 19 degrees is equal to the adjacent side 13 over the hypotenuse C. Well, I'm going to need my calculator for this type of problem. So what I can do, we can use our calculator to solve for the cosine of 19. What I would need to do, by the way, this is a degree. So we would need to be careful to make sure that we have our calculator in degree mode. Our calculator has 2 modes. Please hit the mode button on your calculator, which is right next to the second button. Look at your calculator. You've got the blue second button right next to it is a mode. So hit mode, make sure it's in degree mode. Okay, now I select cosine of 19 degrees and gives me 0.9455. So 0.9455 is equal to 13 over C. I'm going to have to put that over 1, and I can solve for C by just cross multiplying and get 0.9455 over 1 equals 13 over C, and I get 13 equals 0.9455C. And I just divide both sides by 0.9455. Those cancel. And I get C is equal to 13.75 feet. Well, it doesn't really say feet, I'm just going to make that assumption. So let's put this up here, 13.75 feet. And now, with that piece of information, I can also solve for A. So let's put a line here and say that with opposite and a hypotenuse, I can say that the sine of 19 degrees is equal to A over my newfound, this is an A here, hypotenuse, 13.75. So I go back to my calculator and say the sine of 19 degrees is equal to .3255. 0.3255 is equal to A over 13.75. Let's set up the ratio. And A equals 13.75 times 0.3255. Multiply those together, and we get A equals 4.48. A is equal to 4.48 feet. Okay? All right, we're going to stop right now, and we'll do the next two problems on another video. We'll do that in part 2. Okay?